Okay, so today's lesson in Math 4 is related to trigonometry, and this would be a very long chapter actually. So in principle, the people who were actually my student, they know about these subjects before, but I do not consider everything. I don't consider that you already remember that. So I will start everything from scratch today. So it would be more or less everything that you need. And the next lesson would be a new lesson actually in trigonometry. I don't know how much Natur students have already learned about the trigonometry in the unit circle. Usually trigonometry in corner situation, because it is in the last chapter, might be you haven't had that much time to focus on it. Okay, but let us start the lesson. So in geometry, actually, we have the notion of angles, yes. But angles are measured, for example, in degrees. And then the smallest angle we face in geometry is the angle 0 degrees, yes. And the largest one is probably 360 degrees, yes. But now, if you take your calculator and then, for example, punch in sine of, I don't know, 420 degrees, you get an answer. Okay, so in principle it means that somehow the calculator knows that even 420 degrees is a sensible angle, yes? But so this one, I want to give meaning to these. So first of all, I want you to be ready that in trigonometry we have angles bigger than 360 degrees. So for example, 1280 degrees is completely okay in trigonometry. And we also have negative angles. So if I tell you minus 30 degrees, that also makes sense. But how it makes sense, we want to give the definition here, and now we understand what is the convention behind that, so that we can talk about negative angles, angles larger than 360 degrees. And that is the notion of the unit circle. I would say that it's not exaggeration if I say that if you learn the notion of the unit circle, then you are okay with trigonometry 70%. Yes, so it's extremely important, but it doesn't mean it is hard. It's not hard at all, but you need to master it and try to practice on it. So let me start today's lesson by introducing you what the trigonometry in the unit circle. By the unit circle, this is a word in mathematics, this is a standard. When I say the unit circle, I mean that consider the coordinate systems as usual, x, y, and this origin is O, and consider a circle whose center is at O and its radius is 1 unit, whatever length unit you are using. Yes? So let me just try to draw a circle here. Okay, I try to draw it a little bit big, but consider that this radius is 1 unit. Yes. Might be it is easier for me to draw the circle first and then the coordinate system. So let me try to do it in that way. Yes. Because then I want to adjust myself with the coordinates. That would be hard for my brain to do it. Yes. Okay, something like this. So if someone asks you where the center of the unit circle is, by convention it is the origin. And if someone asks you what is the length of each radius of this circle, you would say it's 1 unit. Okay? And then we want to pick up an origin for the unit circle, and that by convention here, so let me call it A. So I will consider the point A to be the origin of the unit circle. It means that, and by convention, if I go counterclockwise, I consider it the positive direction of rotation, and if I go clockwise, I consider it the negative direction for angles. Yes? And then remember that if you want to talk, if you have an angle, one side, one leg of that angle by convention is always OA. Yes? So because you have an angle, so you have two legs. One leg is always assumed to be OA, and the other angle is free to rotate. Yes? For example, if I ask you, for example, show me positive 30 degrees, then what does it mean? It means that your first leg of the angle is here, and because I have mentioned positive, it means that I have to start rotating about the point O in the positive direction with 30 degrees. Yes? So I start here and I rotate 30 degrees. For example, I don't know exactly, but assume that you end up here. So this would be positive 30 degrees. And then this is extremely important in trigonometry. What matters is usually not the size of the angle. What matters is this final point, which is associated to that angle. Is that understandable? So be careful. From now on, we will see why the size is not that important for us. Of course, it is important, but something more important is this final end point associated with this angle. I can similarly talk about negative 30 angles. But does it mean? It means that again, as I told you, I start the same place, but I rotate this time in the negative direction. Yes? So it means that, for example, I start from here, 30 degrees I rotate about O, but in the negative direction, which means this. So then here I get this point, and if I ask you what that angle is, you can call it minus 30 degrees. Yes, is that understandable? And now it becomes clear. I can talk about, for example, where would be the final point of the angle corresponding to 0 degrees? Can you just call it, give it a name? Where is the final point for 0 degrees? A itself. Yes? So let me give these names. I want to practice a little bit. So here A, B, C, D. Okay. Can you tell me where is the final point of 360 degrees? Yes?
Also A.
Also A. What is the final point for 180 degrees positive? What is the negative 180 degrees? Is again C. Yes, it's understandable. So where is 270 degrees? The final point is D. Yes, is that understandable? Can I come to D with a negative angle? So you saw that I came to this angle, to this position with 270. Can I come to this with a negative angle? What that angle is? Minus 90 degrees. Yes, so it is clear, isn't it? I can also imagine angles bigger than 360 degrees. For example, and I think you intuitively know what I mean. For example, if I want to go to 390 degrees, let us see where I end up. It is bigger than 360 degrees. So it means that I start here. I start rotating about O. When I do not put a sign, it means that it's positive. So I have to rotate in the positive direction 390 degrees. So if I start from here and rotate back up to this point, it is still not enough, because how much I have covered so far? 360 degrees. But I have to cover 30 degrees more. And when I cover 30 degrees more, where do I end up? Exactly the same blue point. So you see that if I want to address this point, the best possible way probably is telling 30 degrees, then I will be here. But how many angles do you think I can give? How many angles will end up with this point? How many? How many? Infinitely many, yes? Agree? Because if I just go 30 degrees, I end up here. If I go one full round and then 30 degrees more, this angle, I will end up here. But there is no reason that I just turn one round. I can turn 2 rounds and then go 30 degrees more. If I go 2 rounds, it would be 2 times 360 degrees, which becomes 720. And then add 30 to it, it becomes 750. So you see, angle 30 degrees is completely different from this angle, and it is completely different from this angle. These angles are not equal at all. This one is much bigger. But what do they have in common? They end at the same point on the unit circle. Is that understandable? Okay. And the end point will matter for us. This is extremely important to understand that. Okay. So now we understand what is this unit circle somehow, but now I want to define you give me a trigonometric angle. When I say trigonometric angle, it means that I have an angle that might be positive, might be negative, or even greater than 360 degrees. When I say trigonometric angle, I mean this. Okay? So now I want you give me a trigonometric angle. The trigonometric angle has two legs. I put one leg of that angle here, and then the other angle is not under my control. It depends to the size of the angle that you tell me. But you know that based on this method, it will end up somewhere on the unit circle. Agree? It doesn't matter if it is very big, it's very small, positive, negative. I will end up somewhere on the unit circle. Yes? Okay, now assume that, let me clean this. Now assume that you give me a trigonometric angle theta. So this Greek alphabet are used extensively in trigonometry. This is called theta. So assume that you give me this trigonometric angle theta. I take that angle, I put one leg of that here, and then depending to the size and depending on the sign of this, I will start rotating in this direction or the other direction. Eventually I end up somewhere on the unit circle. Okay? So for the time being, let us consider that I ended up somewhere here. Okay? So let me connect this one to this one. Theta might be this is theta. We don't know because we don't know the size. But who knows? Might be theta is this angle. Yes? Might be theta is this angle. We don't know. But we know theta is a trigonometric angle. We end up somewhere. Okay? Now forget about the angle and forget about the unit circle momentarily. You are left with a coordinate system and you are left with one single point. Every point in this coordinate system carries two numbers, x coordinate and y coordinate. So let me call this a point whose x coordinate is x, whose y coordinate is y. Yes? And now we define, this is definition. Definition tells you that sine of theta, I put a semicolon equal. Semicolon equal means defined to be equal. Because when I put equality, in principle, I should motivate you why equality is true. But when I say semicolon equal, it means that I am defining this to be equal. So it means that there is no burden of proof on my shoulder. Okay, so sine of theta is defined to be what? Is defined to be the y coordinate. Yes? And cosine of theta is defined to be the x coordinate. And there is another one which we call tangent of theta. It's defined to be the y coordinate divided by the x coordinate, but for natural reasons, the x coordinate shouldn't be equal to 0. Otherwise, that doesn't make sense. Okay, let me repeat. So you give me an angle, you give me a trigonometric angle. I put one leg of that angle here, I end up somewhere. That would be a point. That point has two coordinates, x and y coordinates. I am telling you that this number y is called the sine of that angle. This number x is called the cosine of that angle. And if you divide the y coordinate by x coordinate, what you get is called the tangent of that angle, as simple as that. Is that understandable for everyone? It's a very simple concept, yes? Okay, let me try to test your understanding now. Without any calculations, I want you to tell me what is sine of 90 degrees. And what is the cosine of 90 degrees? And what is the tangent of 90 degrees? And by the way, if you have your calculator handy, There are two modes that you can use trigonometry, and we will study both of them this year. One of them is degree mode, the other one is the radian mode. But for the time being, switch your calculator. It's better to have it handy with you. Or you can use GeoGebra if you have your computers in front of you. And I don't know, everyone is familiar with GeoGebra? No. Okay, so we have to also start working on it. I will try to tell you what to do. But anyway, if you have your calculators available, punch sine of 90 degrees, you should get 1. If you don't get 1, it means that you are in the radian mode. Learn how to switch it back in your own calculator to the degree mode. Okay? For the time being, let us keep up with degrees. Okay, now I want you to understand what is going on here. Okay, so let me clean this. We don't need. You know the positive direction is counterclockwise and things like that. Okay, so if I ask you, tell me what is the number of sine of 90 degrees, how you should think about it. You should say that I put the leg of 90 degrees, one leg here, and I start rotating about 90 degrees. Because 90 is positive, I rotate in the positive direction. And where do I end up with? B. Yes? So I rotate and I end up with B. So what matters for 90 degrees is this B. And read the coordinates of this B. This B lies on the y-axis. So what is the x-coordinate? 0. What is the y-coordinate? Why it's 1? Because I told you that the radius of the circle is supposed to be 1. So from here to here is 1 unit. So it means that the y-coordinate is 1. And now you need to remember this definition, by the way. Try to work on your memory. Sooner or later you have to. So sine of theta is equal to the y-coordinate. So if I ask you what is sine of 90 degrees, what is your answer? 1. What is cosine? 0. And what is tangent? Tangent is supposed to divide y by x, but you divide 1 by 0. It's undefined. Okay? So it's undefined. And you can check it with your calculator. Sine of 90 degrees, if you check it, it should be equal to 1. Cosine of 90 degrees should be 0. And if you punch tangent of 90, you get some kind of error probably. Yes? So as simple as that. But you need to practice. This is a very, very important notion. I will try to practice around this. Okay. Now let me ask you another question. Can you tell me what are these? What are these? So again, let me repeat the process. This is the last time that I will repeat the process. I put one leg here. I will start rotating 180 degrees about O in the positive direction. So where do I end up? C. What is important is the coordinates. So what are the coordinates? It is on the x-axis, so the y-coordinate is clearly 0. What is the x-coordinate? What? Minus 1. Because it is on the negative part. It is still 1 unit, but it is on the negative part. So it is minus 1. So now answer me, what is sine of 180 degrees according to the definition? It's the y-coordinate. So it is 0. Yes? And what is cosine? Minus 1. And what is tangent in this case? You have to divide y, which is 0, by minus 1. What would be the answer? A fraction whose numerator is 0 is 0. So these are the numbers for tangent of 180 degrees. Yes? So it is simple. So let me just do one more practice here. So for example, what is sine? So what is sine of 0 degrees? Cosine of 0 degrees. This is immediate actually. So what are these? Can you imagine and tell me what is sine of 0 degrees immediately? Yes?
Sine of 0 is 0.
Yes?
Cosine of 0 is 1. And tan of 0 is I'm not sure.
No, why not? Divide y by
It's
x.
undefined. Because...
No?
Or no, it's not.
It's 0 again.
0 over...
So, be careful. A over 0 is undefined. 0 over a is 0. Yes, if of course a is not equal to 0. So how did you come to this conclusion? Because what matters is the a, are the coordinates of a. Do you agree? Because the final point and the initial points are the same for the 0. So what are the coordinates of a? 1 and 0. So this the y coordinate is 0, this one, and I divide 0 over 1, which is 0. So that is tangent of 0. So if I immediately ask you about this, do you need to pay attention that much to the details, or you can immediately talk about it? You see what is important? Where actually is the final point corresponding to 360 degrees? Name it, it's A. So why we should bother even think about it? Everything would be the same. Yes? So sine of 0 degrees is exactly equal to this. Even though the angles are quite different. 0 is much smaller than 360 degrees, but the sines are the same. And what about the cosines? The same. The tangents are the same. Agree? Okay, let me ask you one question. What do you think? So this is one way. This is very simple, but let me try to make it more fun. Okay, so what do you think would be the relation? What do you think would be the relation between sine? I don't know if you have it in your memory or not, but assume that you don't know. Sine of 30 and sine of 750. So what is the relation between these two? Try to imagine the angles in your head, detect the final points, and see what happens. No calculator is allowed, just your head. Yes?
They end up at the same point, so they're the same.
They are the same. Do you agree? So do you agree that 30 degrees and 750 degrees end up at the same point? Can you imagine that? So okay, I don't need to explain. So it means that the final points are the same. So what matters is the final point. Yes? So sine of this and sine of this are equal. Yes? Even though the angles are quite different. Yes? And let me ask you another question. What do you think about the sine of 30, this time not with 750 degrees? This is a higher level question, and I want you to understand that. Try to imagine that. Of course, it is very hard to convince you on the board because I cannot draw precisely, but I can. I'm sure that you understand what I will try to explain here. Let me ask you questions. Do you think these 2 points are these 2 angles end up at the same point? No, it's clear not. Yes? So 30 degrees means that I start from here, rotate 30 degrees, and I end up somewhere here. Yes? But what about 150 degrees? 150 degrees. I start from here and I start rotating 150 degrees. Where do I end up? Let me ask you, do you think it is reasonable that I end up here? Of course, I do not have protractor in my hand, but it is completely intuitively clear. Do you think that I will end up here? No. Okay, do you think that I will end up here? So, where do you think I will end up? You can say something to me, exactly. If you have good imagination. Yes, Aman?
At the y coordinate of symmetry.
So exactly. So you mean I will end up at the opposite point. That is important, yes? Because, let me ask you some question. If I have the mirror image of this point, let me call this point A. This point has 2 coordinates. We don't know because I don't know this angle. But I know that there are 2 coordinates, x and y. I hope that you agree with me that if I find the mirror image to this, it means that this angle is 90 degrees. And if I find the intersection point and connect it to here, even though my picture is awful here, but if I ask you what that angle is, you can answer me. What is the size of this angle? Do you agree? If it's completely symmetric, even though in my picture it is not. So if this is 30 and I do this mirror image, you don't have any doubts that this angle is 30 degrees. Okay? But I told you that you should always measure the angles from this line. Okay? So if this means that if I ask you to give me a name for this angle, you cannot say 30 degrees. Because 30 degrees is the angle from here to this line. But you have to tell me the angle here and this original line. So what is the angle between these two? 150. So this point, which is on the one hand the mirror image of this point, on the other hand corresponds to 150, ends here. Now tell me, if I call this point B, what is the relation between x coordinate of B and x coordinate of Y? What is the relation between y coordinate of B and y coordinate of A? Which ones are the same? Y's are the same. Yes, this is the same height. So if I call this y, even though I don't know what y is exactly, who cares? If this is y, this is also y. But now if that is x, what is this one? Minus x. You see? So that is the only thing that you need to be careful. So this is not something that I can teach you for each case. In each case, you should be a little bit careful to understand these relations. After it is done, let me ask you something. Here, if I ask you what is sine of 30 degrees, look at this part. What do you write in front? Y. Yes? If I ask you to tell me what is cosine of 30, what do you write in front? X. Let us put it in a box. Forget about this and let us go back here. If I ask you, tell me what is sine of 150 degrees, which point is important for you? The final point corresponding to 150 degrees, which is, again, y. And if I ask you what is the cosine of 150 in this picture, what do you say? Minus x. Now, you are done actually. Sine of 30 is y. Sine of 150 is also y. So what does it mean? It means sine of 30 is equal to sine of 150. If you ask me what this one is, I don't know. Probably I don't know the exact number. But I know something. I know that sine of this, whatever it is exactly equal to the sine of 150, whatever it is. Yes? And then, can you tell me what is the relation? We can answer more questions here. What is the relation between cosine 30 and cosine 150? What is the relation? Are they equal? No. How is the relation then? One of them is x, the other one is negative x. So they are opposite to each other. Yes? So cosine of 30 is not equal to this, is equal to negative. Yes? So this kind of things you should discover yourself, and this is not hard. It is based on symmetry arguments. Is that clear? Okay. So if you learn this is everything that you really need to learn. By the way, what is the relation between tangent of 30 and tangent of 150? So my question is about tangents. So tangent of 30, how it relates itself to tangent of 150, if there is any relations. Tell me, what is tangent of 30? It should be immediate. It should be a matter of seconds, not minutes, okay? So tangent of 30 is what? Tell me. So tangent of 30 is y over x. What is tangent of 150 according to the picture? Y divided by minus x. But now you know algebra, how they are related, how these two fractions are related. One of them is negative of the other. Is that right? So it means that Tangent of 150 is also negative of tangent of 30. Is that right? Yes or no? Yes? Good. Okay, so let me try to ask you this question, and I want you to yourself go through these kinds of arguments without my help to see if you can do it. What do you think would be the relation between a sine of 60 degrees? Let me make it non-famous angles. So for example, 75 degrees and then sine of 255 degrees. Yeah, try to explore the connection between these two, okay? I paused the recording. I want to wait for you a little bit. Okay, did you discover the relation? Yes? Anyone from Natur program? Yes? Someone? Natur program only. Yes, please?
So we think that, for example, if sin...
No, first tell me the relation. What is the relation?
So if sin was y, then...
No, listen to my question. What is the relation? That is the solution that you're telling. What is the relation? Are they equal? Are they opposite? Is one of them twice the other one?
It's the opposite.
It's the opposite. So that's the answer. So what's the relation? One of them is the opposite of the other one. Okay, now I'm hearing your argument. Tell me, what's your argument?
So if sin 75 is equal to y...
Okay, so let me try to explain once more if in case some of you haven't learned it completely. Please don't shy and ask me questions if you don't understand. Okay, so what we know, we want to say something about 75 degrees. Of course, I do not have any protractor, but 75 degrees might be here. And you really don't need to be very precise. Okay? So let me give this point a name. Let me call it M. And then I'm assuming that this is 75 degrees. Okay? And now I want to talk... Okay, what do you say for the other one?
So if it is equal to y, then you have to think, so how much do you have to go to get to 255 degrees? And that's 180 degrees.
Plus 75 degrees. Yeah, exactly. So that's the rule. Thank you very much for this nice explanation. So you start from here, and if you want to go 255, so these are your anchors. Yes? So if I go up to here, it's not enough because so far I have covered 180. So it means that I have to continue. But how much should I continue? Exactly this number, 75 degrees. Yes? So it means that I will come up to here 180 and I will continue. How much more? How much more? Exactly 75. Is that understandable for everyone? Yes, because 75 plus 180 becomes exactly 255. Yes? Can I say that this point, let me call it N. Can I say that this end point corresponds to 75 degrees? No. Because 75 degrees is the angle between them. I told you that every time that you want to give an angle for an endpoint, you have to start from here. Yes? So if I start from here, what is this angle then in total? 255 degrees. Okay, now you can continue. Let me call the coordinates. If you ask me, Babak, do you know these numbers? I would say no. For this case, I had it in my memory. But for 75, no. Okay? So if you tell me, do you know X and Y? I don't know. But I don't need to know for this question. What I need to know is to read assume that this is X and Y and try to understand what are the coordinates here. Now, can you tell me, what are the coordinates here? Pardon? Yeah, what is that? You are answering me a question. Amanda, that was your name?
Yes.
Yeah, so just continue. What are the coordinates?
Minus x and minus y.
So is this understandable for every one of you? Because this is exactly this point reflected through this point. So if the coordinates are x and y, it means that from length point of view, this length is exactly equal to this length, but in opposite directions. So if this is called x, this is minus x. And the same thing for y. Is that understandable? So this is minus x and minus y. Now let me ask you, if I ask you to write something below this, what do you write? That is sine. What do you write? Y. This is definition. Sine of 75 is y. But now let me ask you, what do you write below this? Minus y. Yes, so you write minus y. So this number, whatever it is equal to y. This number, whatever it is equal to minus y. So if I ask you what is the relation between this and that, you would say it is negative of that. Agree with me or not?
Yes.
Okay? So we don't know what that number is. If you ask me what that number is, I have to use my calculator. If you ask me what that number is, I have to use my calculator. But without calculator, I'm completely certain that whatever this is, this relation holds. Yes? This is important. You should be able to discover these properties yourself. And now can you tell me immediately, what is the relation between cosines and tangents? Okay, 5 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, finished. Yes? What is the relation between sines, cosines and tangents?
Cosine is x and minus x.
No, tell me what is the relation. You are right. The answer is right. I know that you understand. But when I ask you what is the relation, you should say they are opposite, they are equal, they are opposite. That's it. What is the relation between tangents? Yes, yourself.
Me. Okay.
No, yourself. What's your name?
It's equal to.
Yes, it's equal. Yes, tangents are equal. Why tangents are equal? Thank you very much. Because if I ask you what is tangent of 75, you go here and find the final point and you divide y by x. And if I ask you what is the tangent of 255, you go to 255 and divide the y coordinate by the x coordinate. But the y coordinate is negative y and the x coordinate is negative x. But this is a simple algebra. These minus signs cancel, yes? So this becomes y over x. So you see that these two numbers are the same. Is that understandable?
Yes.
So what was your name? Sorry? What? Zinur. Okay. Yes, so I think now in the right track, more or less. Let me make sure that you are on the right track by asking you this question. What is the relation between sine of 15 degrees and cosine of 75 degrees? Now I changed the question a little bit. Here, so far, I was comparing sines together, cosines together, and tangents together. Now I am changing this a little bit. I am asking you to find a relation between sine of an angle with cosine of the other angle. Again, these kind of things can also work. Yes, I want to wait for you and then hear your answer. Okay, now who wants the answer? Yes, you should dare to answer, yes. And it doesn't matter if it is wrong. Yes?
I can try to answer.
Yes? First, give me the relation. What is the relation between these two numbers?
They both have an equal distance from one of the axes.
Oh, this is something that you should think about and give me an answer. What is the relation between these two numbers? What you are telling me is how you thought about the problem. And how you thought you get to a conclusion. What is that conclusion? Tell me that one first and I will hear your argument.
The conclusion
Yes.
that they are equal.
Yes. So whenever I say what is the answer, you should say they are equal. And then if this is true, then I will hear yours. Now I am ready to hear your argument that that's a very nice discovery. Sine of 15 degrees is cosine of 75 degrees. Yes? Now can you tell me why? So this is a real mess. Let me start here. Yes? Okay, so what should I do?
I just sketched out
Yeah, and that word is very nice, sketch, because some of you are really get used to making everything precise. You do not have enough tools all the time. A sketch is the best thing to do. Okay, so you sketch 15 degrees, for example. Yeah. Something, I don't know how much is 15, but let me just assume that, but who cares, yes? So this is, for example, 15 degrees.
And then I sketched out 75 degrees.
75 degrees. So when you say I sketch 75 degrees, remember this. I have seen these mistakes from student side. Some of them continue from here. No, when you say 75, again you have to return back and then move. Okay? So 75 degrees will, for example, is 75 degrees here? No, where it actually end up? It usually, so if I go up to here, I have reached to 90. So I have passed 75 degrees. So I have to stop before that. But how much before that? Exactly 15 degrees before that. Yes? So I will start here and then I will go up to 75 degrees. So it means that I have to stop before reaching to 90 degrees. But how much from size point of view, this is again 15 degrees. But if I ask you, where is 75, you show me this. So I am on the right track. 15 degrees, the end point. 75 degrees, the end point. Yes, so let me call this point A and call it X and Y, and then let me write it B. And now you should tell me, if I want to succeed to find a relation, I should be able to use symmetry arguments to write something here. And that I want to hear from you. What do you write there?
You write the x coordinate for B is the same as the y coordinate.
Exactly. So you write y and x, the other way around. But how did you motivate yourself? So what Dennis is saying is that if this is x and y, if you ask me what is x, I don't know. What is y, I don't know. But if they are x and y, what she's claiming is that this should be y and x. This is what you are claiming. Yes? And then I don't know. You should be able, it's very simple, just symmetry. You should be able to convince yourself that this is the case. Okay? How can I convince myself? So that's correct. Thank you very much. So how should I convince myself? For example, I can concentrate on this small triangle here, 90 degrees here. So this triangle. When you say that the x-coordinate is x, it means that this length is how much? Is x. Yes? And what is this length? It's y. This is clear if this is x and y. But now let us concentrate on this narrow triangle. Yes? Using symmetry arguments, I hope that you convince immediately that this triangle is congruent with this triangle. It's exactly the same. Yes? But rotated a little bit. Yes? Now I ask you, if this length is x, what is this length? What? X. Yes? If this length is y, what is this length? This is also y. Agree? But now, x, this number from here to here, plays the role of the y coordinate of B. If I ask you, show me, point something for the y coordinate of B, definitely if you understand what is the meaning x and y coordinate, you would say this is the y coordinate of this point. So if this is x, the y coordinate of point B is x. Is that understandable? And then if I ask you what is the x coordinate of B, you will point this length, and that is the x coordinate of B. Okay? Now, in this picture, if I ask you, tell me something about sine of 15 degrees, you would say sine of 15 degrees is the y coordinate. If I ask you what is the cosine of 75 degrees, you go to B and read the x coordinate. But what is the x coordinate here? Again, y. So on the one hand, this is equal to y. On the other hand, this is also equal to y. So it means that these two numbers has to be the same. If you ask me what they are, I don't know. But I know something. If you don't believe, you can use your calculator to calculate sine of 15 degrees minus cosine of 70 degrees. If your calculator is capable of calculating precise values, it definitely will give you 0 exactly. Yes? So, is that understandable? So this is the whole point of the unit circle. If you really understand them, then you are guaranteed to don't have any problems here. Okay? Good? Okay, one more and then we will try to pass from this topic, okay, and then explore the consequences of what is happening. Okay, what do you think about sine of, let me keep it 15 degrees again, but this time and I ask you the cosine of 255, I think is good. Yes, I want to wait for you to explore this. If you can explore it quite well, then we are done. You don't need to be worried about anything. We can go further. Okay, now who wants to answer? Yes, please. What's your name?
Ima.
Ima. Yes?
I think they're opposites.
They're opposite. Yes, thank you very much. So I want to hear from you. So I think we can continue in this figure because we have 15 degrees here and 255. Okay, let me just draw another one. So here, okay, so 15 degrees as is proof. So let me not explain it that much. Assume that this is 15 degrees. Okay, now I want to hear your argument. Yes?
Cosine of 255 is 15 degrees from D.
Exactly. This point was D. So what you are saying is that if I start from here, as I have to, and then I move and move up, if I reach here, it means that I have already passed that 250 degrees. Because if I reach here, it is 270 degrees. So I have to stop before that. But how much before that? Exactly 15 degrees. Yes? So I will stop somewhere here. So unfortunately my picture is not good, but if you draw it in a very precise way, you can understand that this is exact. If I ask you what is this angle, you would definitely say 15 degrees, but what is the original angle is exactly the angle that I need, which is 255 degrees. And then you can immediately use the symmetry argument. Now tell me, if the coordinates are x and y here, what you need to do is only to read the coordinates here. So let me call it B. So what would be the coordinates? Yes?
Minus x and minus y.
Minus
Y and minus x.
minus y and minus x, because you answered correctly. Minus y and minus x. Yes, am I right?
Yes.
So let me see. No, but you answered correctly. So otherwise you have missed the correct answer. So it means that you are now making a mistake, not when you answered. Okay, so here I considered this triangle and this triangle. Yes, do you agree? Okay, so now I hope that you agree with me that from the size point of view and everything, these two triangles are congruent. Yes? And now when you say that x is the x coordinate, it means that this length is x. So if I ask you what is this length, if this is 5 centimeters, it's 5 is completely wrong because this is a unit. Assume that this is, I don't know, 0.7 centimeters. If I ask you how many centimeters is this one, what is your answer? This one. But if I ask you what is the coordinate, you should put a negative one for it because it goes in the negative y direction. Yes. So this one, if this is x, this is definitely minus x. If I tell you this is x and y, so this is y. If I ask you what is from the size point of view, this and this are the same size, but for coordinates, This is minus y. Do you agree? But now I am asking, this minus y for this point is the x coordinate or the y coordinate? It is parallel to x-axis, so this is the x coordinate. So if the x coordinate is minus y, and the x coordinate is, sorry, the y coordinate is minus x. So Ima, do you understand now? Is that clear? Yeah, I think you did it correctly because your answer was correct. Okay, now if you tell me I want to write something on top of that, what can I write on top of this? Sine of 15, so I refer to 15 degrees, I find the final point, and I read the y coordinate, which is y. I want to write something for this. I refer to 250 degrees, 55 degrees, which is this point, and I read the x coordinate. I have already done that. What is the x coordinate? Minus y. So one of them is y, the other one is minus y. So they are opposite to each other. Is that understandable? Yes? So if you want to test it using your calculator, you can write this plus this. If I have done everything right, this should be exactly 0. You can check it with your calculator. Yes? Is that understandable now? Okay. Now I think you are, so the only problem is that you shouldn't forget about these things until the next session. So you have to review somehow. You don't need to watch all the video, but you can go through it. For example, if this is 1 hour and a half, you can just finish it in 20 minutes. Just skip many parts and see that you can do that. Okay, now let us explore the consequences that is coming. Okay, so this is very important. We learned that. Now we go back and we want to find some trigonometric relations and identities, which is a very important topic in our lesson. Okay, so let me highlight some facts in front of you, okay? So here we have the unit circle. Am I recording? Yes. So here, x and we have y. Okay? So I would say let theta be a trigonometric angle. Trigonometric angle. Okay. So something that I want to tell you, is it possible that I have sine of theta to be 2.3? Is it reasonable or not? I don't know. I haven't given you the size and the sine of the angle, but I'm asking you, imagine one trigonometric angle. Is it possible that sine of theta turns out to be 2.3? Why not?
Because it's the unit circle, so...
Yes, exactly. Because sine of theta, it doesn't matter what the size is, it ends up somewhere on the unit circle. Okay? So it means the highest value for y is 1, the lowest value for y is minus 1, and the same is true for x value. The highest x value is 1, the lowest x value is negative 1. So, sine, which is the y value of that point, cannot be greater than 1. Can it be equal to 1? Yes. If I accidentally end up exactly here, this becomes equal to 1. But other than that, it is always smaller than 1. So it means that this is not possible. Sine of theta is at most 1, at lowest minus 1. It's very important to remember these facts. Another thing, can I say something similar for cosine? Yes or no? Cosine is also at most 1, minus 1. What can I say about tangent? Is there any bound for tangent? Tangent doesn't have any bounds, yes? Why? Because tangent is defined to be y divided by x. Yes? Okay, you see, if I get closer and closer to 90, what is happening? So if I stand here, this is the x coordinate. Yes? But if I move a little bit higher, what happens to the x coordinate? The x coordinate becomes smaller. If I move higher, the x still becomes smaller. Yes? On the other hand, y value is growing. Yes? So when I go here, the y value goes up. On the other hand, x value goes smaller. So it means that I am facing a fraction whose numerator, it becomes large, and at the same time, its denominator goes close to 0 when I am approaching this. So if I have a fraction whose denominator, just only denominator, forget about the numerator. If the denominator is a very negligible number, what happens for the fraction at the, it becomes huge, yes? If I have it, so it means that there is no upper bound. So tangent can go up to infinity. Of course, infinity is not a number. This is a symbol we use in mathematics for infinity. And then from the lower bound, it goes to minus infinity. So in principle, I am not, so it means that if you don't know anything about theta, you cannot say anything about tangent. Tangent can be any number from minus infinity to positive infinity. Yes? This is one thing that you need to remember and extremely important. Another thing is that you need to have a good visualization immediately to tell me if sine of an angle is positive or negative. You should be able to do it immediately for cosine and tangent. Okay? So, by the way, this is a convention. This part is called the first quadrant. So we go counterclockwise. The way of counting is this is the first quadrant, this is the second quadrant, third and fourth. So this is convention. So this is the first quadrant, second, third and fourth. Yes? Now I am asking you, so if, let me write here a table for you. I don't tell you memorize that, but you should immediately visualize and extract the information that you need according to the problem at hand. So here, let me write the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Yes? Okay, tell me, sine, if you are in the first quadrant, if your angle, it doesn't matter if it is big or small, negative or positive, it ends up somewhere in the first quadrant. Sine, cosine, tangent, are they positive or negative? Here. That's clear. If you end up somewhere here, x and y coordinates are both positive. So it means that sine, which is the y coordinate, is positive, cosine is also positive. And if the y and x are positive, so its division is also positive. Okay, can you fill up the columns of this table for me immediately? Number 2. What is the first sign? Positive or negative? Imagine it in your head. You end up somewhere in the second quadrant. Positive or negative? Positive, because it is still the y value. Cosine? Negative. Tangent? Divide them, because y value divided by x value. It is negative. Yes, here. Tell me. The third quadrant. Negative. Negative. Positive. And then? Negative. I don't say that you memorize them, but this is, you should extract this information in a matter of seconds, yes? So you visualize and then extract the information. This is another thing that I want to bring it up. Another thing is a very fundamental relation between sine and cosine. It's a very fundamental, this is probably the most important formula in all trigonometry. Okay, to do this, I want to remind you something from Math 2C. I want you to answer me. If you remember, you had a formula, it's called the distance formula. So if I have 2 points in the coordinate system, I have point A with coordinates x1 and y1, and I have another point with coordinates x2 and y2. Yes? If I am interested in measuring, not measuring, measure means I should have a tool. If I want to calculate the distance between these 2 points, which I call d, do you recall the formula? Which is actually an implication of the Pythagoras Theorem. Yes? So, you remember?
The distance formula.
The distance formula. Of course, if you don't remember, in principle, you should be able to immediately extract that, yes? Because then what you do, you would say that from here to here is x1, from here to here is x2, so from here to here would be x2 minus x1. Yes? And then from here to here, and the same thing. Here it would be y1 minus y2. Yes, in this picture, it's a little bit unfortunate. One of them is x2 minus x1, the other one is y2 minus y2. And then you can immediately use the Pythagoras Theorem, yes? So d, which is the hypotenuse, is equal to the square root of this number to power 2. So let me write it x1 minus x2 to power 2. Is there any difference here? Of course, x2 minus x1 is different from x1 minus x2, but they differ at the opposite sign, at the negative sign, which power of 2 will kill that one. So there is no difference. And the same thing here, plus y1 minus y2 squared. So do you remember something like that you had in Math 2C? That's the distance formula. And now if I want to use the distance formula to measure the distance of a point to the origin, what will happen? OA. What is this distance? This is the same formula, but I know the coordinates of the origin. The coordinates are 0 and 0. So what does it mean? It means this is 0, this is 0. So if I want to measure the distance from any point to the origin, what I need to do, I write in a square root, and then what I write, I take the x coordinate of the point and square it, take the y coordinate of the point and square it, add them together. So this would be the distance of this point to the origin. Is that understandable? Let us go back here and discover a very important relation here in trigonometry. So let me just draw this picture for you. So here, I want to calculate this combination. I give you an angle, theta. I don't give you the extra information. I don't tell you what is the size. I don't tell you what is the sine. That is a trigonometric angle, whatever you like. And I want to calculate sine of that angle, which is a number, and square it, and cosine of that angle and square it, and add them together. The answer would be exactly equal to 1, regardless of my choice of my angle. That's a very, very fundamental relation, and it is very easy to see why. Why is that? Because you give me theta, I start from here, rotate a little bit according to the size and sine of this angle, and I end up somewhere. But that somewhere is somewhere on the unit circle, yes? So you end up here, and then this has coordinates x and y. Okay? If I ask you, if I give this a name A, and this is the origin, if I ask you what is the size of OA, you can immediately answer without any calculations. What is the size? 1, because this is the unit circle. Yes? On the one hand, this is 1 unit of length. On the other hand, we have a formula to calculate the same quantity. So can you tell me, on the other hand, how should I calculate OA? I need to take the x coordinate, square it. I need to take the y coordinate, square it, and add them together. Do you agree? Okay, on the one hand, OA is 1. On the other hand, OA is this. So what can I conclude immediately? That x squared, the square root of x squared plus y squared is 1. So this means that x squared plus y squared is 1. Agree? So it doesn't matter which point on the unit circle you have. They can have different x's, they can have different y's, but one thing is clear. If you take x and y for the same point and square them and add them together, the answer becomes exactly equal to 1. But now tell me, what is y? How y relates itself to theta? Y is the sine of theta. And what is x? Is the cosine of theta. So it means that instead of x, I put cosine theta to power 2. Instead of y, I put sine theta to power 2. And the answer should be equal to 1. So that is the extremely important formula. And unfortunately, many people even doesn't have it in their memories. Okay? So you should have them. I was thinking that might be, I give you some bonus points if you don't want to have the formula sheet. Okay? But that's good. I can give you, I don't know, 1 or 2 points for free if you choose not to use the formula sheet. Yeah, I think that's a good deal. So it means that if you come to the exam and don't write anything, you get 2 points. Yes? Yeah. That 2 point, I don't know about 2 points or 1 point. It depends how many customers will be there. But yes, try to use your memory, okay? So let me just write a very, very important fact, which we in mathematics, facts are called theorems, yes? Let theta be a trigonometric angle. Then, by the way, we write this. This is also good to know. The most important formula in trigonometry. And this I want you to know. This is a convention. When you see this way of writing, it means calculate sine of theta and then square it. Yes? So, if you want, you can have some footnotes. It means sine theta squared cosine So from now on, if I want to put a power, if I want to have an exponent for sine and cosine, I read it like this. Sine squared of theta, which is probably, technically it is wrong. I have to read it sine theta squared. Because sine squared doesn't make sense, yes? So when I write 2 to power 2, it means 2 times 2. I cannot write sin to power 2. Why not? Does this make sense? No, sin is nothing, yes? It becomes something if I put an angle in front. Sin in itself is nothing. It doesn't have any identities, okay? But when I write sine of 30 degrees, because it becomes a number, I can do whatever I can do with numbers. For example, I can square them, yes? Is that understandable? So it's extremely important formula. Sine squared of theta is plus cosine squared of theta is equal to 1. For example, if I ask you to calculate sine of 22.5 degrees squared, if you ask me what that number is, I don't know at all, okay? But I know that if I add this to cosine squared 22.5 degrees, it becomes exactly equal to 1. Okay? So you see, this is one consequence of that. So in principle, you don't need to be worried about both of them. If you know sine, you already know cosine. Yes? Because you have a formula relating sine and cosine together. So if you know sine, you can put it in this formula and calculate cosine. So this is why one of them is usually enough for your purpose. Is that clear? So yeah. Did you memorize that right now? Yes or no?
Yes.
Okay. So what is the answer to this? Just immediately answer. Okay. When I finish, you should give me the answer. So, what is this one? Immediately. Yeah, wrong. Yeah, so I know how to trick you. This is not 1. Who knows? They are not the same angles. One of them is x, the other one is y. Yes? That's another way of answering your question. Yes? When I use 2 different letters, it is not clear that they are equal. They might be equal, but this is not guaranteed. So if you say this is 1, this is wrong. This is not 1. But let me ask you something. Sine of 2, I put in front of it x plus y, plus cosine to the power of 2x plus y. What is this number? This is 1. Because what is sitting in front of sine is exactly the same, which is in front of cosine. Is that clear? Okay. Now, let me add to this another very important formula. Can you tell me, I have already mentioned that, not directly, what is the relation between sine, cosine and tangent? Yes? Okay. Okay, but what is the relation between these 3 with respect to each other? So you are, of course what you said is right. You are relating them to y and x and things like that. That's completely true. But how they are related simultaneously together, yes?
Tan theta is equal to sin theta divided by
Cosine theta, yes? That's it. So let me add the second important formula of trigonometry here? Because, do you remember I told you that what is tangent is y over x. But what was y? It was sine. What was x? It was cosine. So tangent is sine divided by cosine. So that's it. Yes? Very, very important. Let me ask you one question because I want to make sure that you know. Can I write something like this? Do you think it is true or false? And tell me why. First of all, what is the meaning of this? If I give you a calculator, and if I give you the angle, how do you calculate the left-hand side using your calculator? Give me a step-by-step instructions. For example, I give you tangent, theta is 30. How do you punch this in your calculator? Can you tell me? Yes?
You take the tangent of 30 and then to the root of the 30.
To the power of 3. So you have to punch tangent of 3 in brackets and to power 3. That pair of brackets we omit here in writing. Yes? So you know. But now my question is that, do you think this formula is correct, but do you think this formula is also correct? If yes, why? Yes? Correct or not?
I think it's correct.
Yes? Can you tell me why? I want to go through step-by-step calculations. Of course, it is very trivial, but I want you to understand once. If someone asks you why, you should be able to answer. Otherwise, you cannot say trivial, and then if someone asks you why, you say that I don't know. So it's not trivial, yes? So you should know why this is true. Okay, do you want to tell me the instructions, or I should ask someone else? This is true. Why? A step-by-step instructions.
If the other one is true, that one is just the same thing, but to the power of 3.
3, and using one property of fractions. Can you tell me?
That when you put parentheses over a division, you have to do it on the elimination.
Exactly. Thank you very much. So when you say tangent 3 to the power of 3, this means, as Jakub said actually, you have to calculate tangent of theta first and then raise it to power 3. But tangent of theta is sine theta divided by cosine theta to the power of 3. So pair of brackets, power 3, instead of tangent I have put this. But I have a formula in fractions. When I want to raise a fraction to power n, what was the rule? The rule was that you can raise it to power n in the numerator and in the denominator separately. So now I can raise the numerator to the power of 3 and the denominator to the power of 3. But there is a better way. When we want to write it with hand, we don't usually write it like this. We write it as sine cube theta, cosine cube theta. So from now on, you are completely relieved. You don't need to demonstrate this all the time. Don't do that, please. That would be a mess. When I give you this, if you need, just write it this immediately. Okay? Is that understandable? Okay. Now I think we have to stop here. Yes? We have to stop here, yes? Okay, we stop here and then we explore the consequences. I will try to write something, but I haven't covered yet because this is a repetition from Math 3C and they are not emphasizing on that much. But I know that if I don't do this, we will have problems in the future. Thank you very much. Have a nice weekend.
Nej, men alltså det här handlar ju om